Hello guys, hello students, welcome to my channel, The Study Hub. Today's discussion is about the electricity class 10 part 3. So whatever discussed in the part 1 and part 2, go through that very carefully, and then it will be clear, easy to understand the third part of the chapter electricity. So today's discussions will be about the what is resistivity, and yesterday discussion was what is resistance, the resistivity versus resistance kya hai, and why resistance, why resistivity, what its implications, and also the combinations of resistors or conductors, the parallel combinations, series combinations, both combinations, and then the Joule's law, hitting effect of current, Joule's law. I will discuss this, and after completion this, I will go through the numerical problems. Today's discussion is only theoretical base. So let's start. So yesterday I have discussed about what is resistance, Ohm's law. The resistance, opposition of flow of electrons. The resistance is the property of a conductor, by ability of a conductor to resist the flow of current, the flow of charge, that is the resistance R. And what I learned in the yesterday classes, the resistance R equals to what we learned, R equals to what? The resistance equals to R, iska unit kya hai? Ohm. Okay. The resistance R equals to what I learned, rho into L by A. It depends upon the length, area of cross sections. So in that case, rho, the R equals to rho L by A, resistance out here. Now from here we got rho equals to what? Rho equals to what? That means R A by L. Okay, that means R A equals to rho L. The rho equals to R A by L. We know it. So what is resistance and resistivity? Resistivity. What resistivity? What is this? That is the measures. It is the measures of resistor. The measures of resisting power. It is the measures of resisting power of the material to flow of electric current. Again I am telling, resistivity, it is the measures of resisting power, resisting power of the material to flow of electric current. Resistivity. Resistance, it depends upon the resistivity of the conductor to resist the flow of current. And resistivity, it is the ability or the property of material of the conductor to resist the flow of current. That means it depends upon the material. Clear? It depends upon the material of conductor. Important material. Which material it depends? And it depends, materials not only depend upon the conductor property, length, it depends upon length, it depends upon area, it depends upon temperature, all these things. Resistance depends upon length, area of cross sections of the conductor, temperature, okay, all these things. But it does not depend upon all these things. It only depends upon the material of the conductor. Suppose the material in case of aluminium, in case of copper, in case of zinc, that means material is different. So in that case, resistivity will be different. And again, what we know, same material, suppose copper, iska length differ, iska size, shape differ, area of cross section is difference, the length difference, That means same materials, length and size, shape and size is different. So resistance will be different. Though it is same. In case of resistivity, material is same, shape and size is different. So it does not affect the resistivity. Resistivity will be same. Clear? In case of resistivity, in case of same material, length, shape and size is different, but resistivity will be same. But in case of resistance, same material, shape and size is different, but resistance will be different. It will not be the same. So in case of resistance, the unit we use ohm. Yeah? And it is ohm centimeter or ohm meter. It is ohm meter. Ohm centimeter or ohm meter. SI unit, CGS unit. How we got the unit in case of resistivity? Here, the resistance, area, length. Resistance का unit क्या है? Ohm into area. Area means what? Centimeter square. Centimeter into centimeter. Centimeter square. And length, centimeter. कट गया. Ohm semi. In case of meter square, meter, ohm meter. So in this way, we have got the unit of resistivity. Okay, so this is the resistance and concept of resistance and resistivity, and some difference out there. You must know the resistivity क्या है, resistance क्या है. It only depends upon this L, A, and T. It depends on, it is the opposition of what? The material of the conductor. The material of the conductor. Okay, mind it. Okay, let's start about the resistance of a system of resistors. Okay, resistance of system. That means we have to discuss out here how to combine the resistors. There are different types of combination. The resistance of a systems of resistors. Resistance of a systems of resistors. Okay, that means so many conductors or resistors are connected. How to connect? In case of our everyday life, in our buildings, in our house, in industry, all where we have to connect the resistors by parallel connection and series connections. Series connection series में होगा, series connection होगा, parallel connection में होगा, parallel connection होगा. Series connection, parallel connection. What is series connection? Series connection means two or more than two, n number of resistors, conductors are connected in series. That means one after another. Series means one after another. That's so many. Suppose this is resistor, again this is one resistor, again this is one resistor. As so many resistors are connected one after another. So here is a peak. Okay. Suppose this is R1, this is R2, this is R3. So same different resistors are connected one after another. This is in series connection. So in that case, you have to find out. Here, suppose here current is flow. I current is flow out there. That is potential difference is this. That means in this case, if you want to replace this R1, R2 and R3, instead of this, you have to join only one resistor. Only one resistor. Only one resistor you can use. That is, in case of R1, R2 and R3, you have to use a combination of R1 and R2 and R3. That is equivalent resistors of R1, R2 and R3. You have to use only one resistor. In this case, what happens? Same thing. Okay, that means here the R1, R2 and R3, in this case you have to replace these three resistors, you have to use only one resistor, RS. This is known as the series connection. So what will be the equivalent resistor? What will be the register, you have to find out the value. So how? Here you must know that I current in this series, the current will be same in each of these registers. Same current will flow and same current will be come out. But only one thing, potential difference. Here potential difference from this to this, from this to this. This is V1, from this to this V2, from this to this V3. Clear? That means potential difference. That means here total potential difference of the two ends of a conductor, it will be V1 plus V2 plus V3 will be V. And here same current will flow along with each resistor. Same current will flow. If you put out here and a valve out here, so same current will flow the bulb. Same with each bulb will consume same amount of current and it will glow. Here same amount of current will glow, will be consumed. Clear? That means in this connection current will be same and volt potential difference, it will be that this total potential difference out here, total is V. That means V equals to V1 plus V2 plus V3. But if in this case, this is known as series RS, one combination, it is the equivalent resistance of 3 is RS. You can set it n number of resistors. Here 3, 4, 5, n number of resistors. But in case of parallel, what happens? That is the only common ends. One ends common. Suppose they have two common ends, okay, and this is connected. Okay, this is there is connected, current is flowing through this. This is R1, this is R2, this is R3, and this is connected in series. This is connected in series. Okay, this is connected in series. What we see out there, this is connected in parallel. So if you consider these three resistors, you have to use equivalent resistor. Only one. In this case, R1 plus R2 plus R3, it will be only one resistance are there. Equivalent resistors, and it will be parallel. That is RP. You have to use R1 plus R2 plus R3. These equivalent resistors you have to use RP. But out here, you must remember, here current will be not same. From here, the current will be divided as these are the three different resistors. So resistance will not be same. So same current will not flow. High resistance, low current, low resistance, high current we know. So current will not flow equally in each resistors. So current here will be divided. Suppose here I1, this here I2, here I3. But here potential difference across the two ends will be same. Out here what is potential difference? V1, V2, V3. Here potential difference will remain same, will not be changed. Here I, the total current, will change into I1, I2, I3. That means I1 plus I2 plus I3 equals to I. Yeah, the current will be divided. The same current will not flow in with each resistance because the resistance are different. It will give high resistance and high resistance, the flow of current is low. Resistance is low, high flow of current. So that's why here current flow with each resistors are not same. But here current flow each resistors are same. I. This is the difference. So how to find out the equivalent resistance in series combination and in case of parallel combination? Derive the relations in case of series, in case of parallel. I am coming. But see out here the figure. So find out the equivalent resistance in case of series connection and in case of parallel connection. Okay. So what is the equivalent resistance? Equivalent resistance in series connection. Equivalent resistance in series, that is RS. You have to find out equivalent resistance in series connection. What? Suppose this is I have learned. I have given all this figure in the yesterday picture. R1, R2, R3. different resistors V1, V2, V3, same current flow. Okay, we know. And in that case, we have to replace these three resistors in case of one equivalent resistor, and how to find out the equivalent resistors. So what we know from here out here in series connection, what we see out there, total V equals to V1 plus V2 plus V3. We know this is V. And from Ohm's law, what we learned, V equals to IR. V equals to IR. We know V equals to IR from the Ohm's law. Clear? It is clear. V is equals to IR. That means here V equals to V1 plus V2 plus V3 equals to I R1. I here R1 plus I R2 plus I R3. Yeah, I R1 plus I R2 plus I R3. What V equals to what? VI. That means RS. IR. The V equals to that means IRS. Clear? That means IRS equals to, get the common, R1 plus R2 plus R3. You can write capital R1, R2, R3. Okay? That means IR cancel. That is RS, R3 is equivalent resistor. This is equivalent resistor in series equals to R1 plus R2 plus R3. This is the formula. Equivalent resistance in case of series connection, it will be the sum of the total resistor use. Okay, the equivalent resistors in series will be the sum of the resistors used in the series. R1, R2, R3 ... You can use up to Rn. Yes, this is the sum of. That means if you want to, those 10, 20, 30, then in their equivalent resistance will be 10 plus 20 plus 30 ohm. That is, in this case, resistance will be high. So to minimize the flow of current, you will use the series connections. To minimize the flow of reaction, that is the resistance is high. Resistance high. To 30 to 70, 10, 30, 30, 60 ohm out here. That is, high resistance means minimize flow of electric current. So in this series connection, what you get, to minimize the flow of current, we use the series connections. Clear? This is the equivalent resistance in case of the sum of all the resistors used in the series. Clear? Now in case of parallel. So same thing, parallel mein kya hoga? Now start discuss about the in case of parallel connections. What is the equivalent resistance? Parallel connection, that is series connection, and the resistors are connected in parallelly. In that case, you have to find out the equivalent resistance of the circuit. So what is the equivalent resistance? Let's see. So this is parallel connection. R1, R2, R3, three different resistors are there. Current I flow through this here to here. So see out here. Here current will be different, I1, I2, I3. Why? Because there are three different resistors. If there are resistors are same, what will happen? R1, R2, R3 are same resistors. Then the current will flow. Why? Same or different? This is the questions. Give the reply. Give me reply. Okay? If these resistors are same, in that case, what is the flow of current will be different or same in each resistors? Okay? Question. Give me the answers. But out here, R1, R2, R3 different, so flow of current will be different. Here total I will be divided into I1 plus I2 plus I3. And the volt, V, potential difference will be remain same in case of parallel connections. So let's try. What do you know from the Ohm's law? What do you know? The I equals to V by R. I equals to V by R. From the Ohm's law, we know V equals to IR, I equals to V by R. That means here I equals to V by R. That means V RP. I equals to VR. V by RP. Clear? V by RP. Clear? Equals to I1. That means V by what? R1. I2 V by R2 plus V by R3. Common V 1 by R1 plus 1 by R2 plus 1 by R3. Clear? V by Rp. Vb cancel. 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is in case of parallel combinations. 1 by parallel. In case of parallel combination, it will be the reciprocal of the resistor. Sum of the reciprocal of the resistors. Sum of the reciprocals of the resistors. 1 by R1 plus 1 by R2 plus 1 by R3. So one thing remember, to minimize the resistance, means to flow the high current. In which connections shall I combine? This is the parallel connections. Because 10 and 1 by 10, it is too less. 20, 1 by 20, 30, 1 by 30. If you add this, it is high, 30, 60. But if you add, there will be small resistance. The resistance is low, flow of current is high. So to minimize the resistance, we always apply the parallel connections. It is very important. Clear? And you must remember that each of the resistors, at least the least resistor, in case of parallel connection, the equivalent resistance what you get will be the less than that of the least resistors you have used out here. The equivalent resistance should be the less than the least resistors you have used. Clear? So remember it. Okay, this series connection, parallel connection. Okay. In this case, household wiring, series connections. Because if you cut, same current is flow. If you cut it, all the lines will be stopped. Okay, I will discuss later. Now come the heating effect of current. Now heating effect of current. Heating effect of current. Heating effect of current. What do you mean by heating effect of current? Okay. Suppose this is a conductor. That means so many free electrons are there. If you flow current, that is flow of electron will be there. There are so many ions, atoms are there, so many atoms, electrons are there, whatever you can say. So electron will flow, electrons will flow, flow of electron, flow of negative charge, it will flow. Current flow means key. That means electron will flow randomly flow, and it will be, the figure will be given out there. Okay, figure will be given out there. So when it will flow, electron will flow. So he try to run towards, and it hits the atom or ions present in the conductor. So many ions are there, so many atoms are there. It collides with them. When collides with them, what will have effect? Collide means he will work something. That means it will be work will be done. That work will be converted into heat. So many collisions, so many work, so many collisions. That means work will be changed into heat. That means what we learn in the yesterday discussions, that is what will the if I hit the flow of electron, it is electron flow, current, charge. What you know? That means V equals to what? W by Q. I know. Potential difference are there. The V equals to Y. What? W by Q. Charge, work done to bring a charge, W by Q we know. W means what? Work means energy. Energy means heat. Work, W equals to E equals to, why no? W equals to energy equals to work, heat. And all work converted into outer heat energy. All energy converted into heat energy. That means we can write out here, that is H by Q. That is V equals to H by Q we can write. Okay? V equals to H by Q. From here, what we learn, H equals to VQ. V into Q, very important. H equals to VQ. What I know, V equals to what? IR. Yes, good. V equals to IR. V equals to IR. So if you write I into R into Q, IRQ. Yes, VQ. VQ I R. V equals to IR. So IRQ. Again, what? Q equals to what? Q equals to IT. Yes, that means I R into IT. Clear? That means IR into IT. Yes, IT, I square RT. I square RT. That V equals to I square RT. I square RT from here. Again, if you convert this, V equals to I square RT. Again, what you learn? V square by T. How? I equals to key V by R. If you put I equals to key V by R, I equals to V by R, then it will be V square V by R. Write it. So V square by R T. V square by R square, R cut gaya, V square by RT. That is V equals to, here H equals to, here, sorry, H equals to V square by RT. Clear? So this is known as the Joule's law. Again I am telling, V equals to H by Q, H equals to VQ, V equals to key IR, you put it IR into Q, Q equals to key IT, then IR into IT, I square RT, then H equals to I square RT. So this is known, this is important, this is also important formula, write it. This is also important formula, because H equals to VQ, H equals to I square RT, and this is Joule's law. Joule's law of heating effect of currents. Joule's law of heating effect of current. H equals to I square RT. Again you can convert H equals to V square by RT. V square by RT. How? I equals to V by R. Put the value I equals to V by R. So these are the three main formula. And this is mainly formula of Joule's law of heating effect of current. So what is Joule's law? You don't require to memorize it. From this here, from this law, from this equation, we can conclude the Joule's law. What is Joule's law? Try to conclude. What is the heat? Is directly proportional to the square of the current flow to the ends of the conductor. That means H varies as I square 1. Clear? And H also directly proportional to the R resistance of the conductor. And also 3, H directly proportional to the T. Time, how long you are flowing the current, how long, it depends upon the time. More the current flow, more the heat will produce, more the resistance, more the heat. Okay, more the time, more the heat, more the resistance, more the heat, more the current, more the heat. From this, Joule's law is this. The heat, if you flow the current in a conductor, then heat produced will be directly proportional to the square of the current, and it will directly proportional to the resistance of the conductor, and also it is the proportional to the time by which it has current passed. These are the three. Then this is known as the Joule's law of heating effect of current. Clear? Remind it that all these things is very important for numerical problems. Next day, I'll solve all the numerical problems one by one. So whatever the laws you have got it from the beginning, V equals to IR, N equals to QE, whatever law, whatever formula you have got, remind it, jot it down. I also send it. And next day, I will discuss about the numerical problems. So here I'll draw my ends. Thank you. Goodbye. But don't forget to subscribe it, share it, and like it. Your valuable comment is very important to me. So comment it. Thank you. Goodbye.